Have you ever just stopped and thought about what's happening all around us? Like right now. Your phone, your laptop, your watch, they're all talking to each other all the time. It feels like magic, right? But it's actually the science of digital communication. So in this explainer, we're going to pull back the curtain and see exactly how all this stuff really works.
And we're going to start with a mystery that I think every single one of us can relate to. You're settled in, you're ready for a movie night, you press play, and then you see it. That dreaded spinning circle of doom. Ugh, why does your video keep buffering? Well, that's the big question we're going to solve today. Okay, so to crack the case of the buffering video, we need to look at two key clues in any connection: speed and delay. Think about it like a delivery service, you know? It's not just about how fast the truck drives, but also how long it actually takes to get from the warehouse all the way to your front door.
So our first clue is speed. In the digital world, we call this bandwidth, and we measure it in bits per second. And honestly, the highway analogy is perfect. A tiny one-lane road, it's going to get jammed up with traffic pretty quick. But a massive, multi-lane superhighway lets everything flow smoothly. Streaming a high-def video is like sending a whole fleet of giant trucks. It needs a lot of lanes, or high bandwidth, to get to you without a ton of stops and starts. All right, so clue number 2 is latency. If bandwidth is the size of our highway, then latency is the actual travel time. It's the delay. It's how long it takes from the moment you click play on a show to when that first little piece of data actually arrives at your device. You know when you run a speed test and you see a ping measurement? That's what it's measuring, the travel time for one tiny data packet. So now we know that bandwidth is the size of our data highway and latency is the travel time. But what sets the speed limit in the first place? And what's causing all those digital traffic jams? And here's where it gets really interesting. You can have this huge 6-lane data superhighway, but it doesn't mean a thing if there's a roadblock smack in the middle of it. A lot of the time, buffering isn't because your connection is slow, it's because something is literally getting in the way. So what are these digital roadblocks? Well, there are a few usual suspects. You've got interference from other electronics, physical stuff like walls and even furniture, the actual distance the signal has to travel, and of course, the type of connection you're using in the first place, wired versus wireless. And this brings me to one of my favorite, weirdest culprits, your microwave. No, seriously, when you're heating up your dinner, that microwave is blasting out a frequency that's super similar to your Wi-Fi router, and that can actually mess with the signal and slow your whole connection down. How wild is that? Okay, so we get the signals and we get what can slow them down. But where do these signals actually travel? Well, they travel on networks, and these networks come in all shapes and sizes, from the tiny little one connecting your headphones to the gigantic one that connects the entire planet. Let's start with the smallest one, the Personal Area Network, or PAN. This is the network that exists in a little bubble right around you. When your smartwatch syncs with your phone or your wireless earbuds connect to your laptop, boom, you've just created your own little PAN. Now take one step up and you've got a local area network, or LAN. This is probably what you have in your house or at the office. It's the thing that links your computer, your printer, your game console, and your smart TV all together, so they can talk to each other and share one internet connection. And then we have the biggest of them all, the Wide Area Network, or WAN. A WAN connects different LANs together across huge distances. So when you stream a movie, you're using a WAN to connect your home LAN to a server that might be hundreds, even thousands of miles away. And the biggest, most ultimate WAN of all? Yep, you guessed it, the internet. So we have signals, and we have the networks they travel on. But what are the actual tools, the specific technologies, the cables, the connections that make this all happen? We use these tools every single day, most of the time without even thinking about it. Plugging your headphones into your phone, transferring files with a USB drive, connecting your game controller with Bluetooth. Each of these is a very specific type of connection doing a very specific job. It's all digital communication. And this brings us to that classic debate, wired versus wireless. Think of a wired connection, like an Ethernet cable, as your own private, secure tunnel for data. It's super fast and super reliable. Wireless, on the other hand, is kind of like an open field. It gives you freedom, portability, no messy cables. But that signal can be weaker, and it's way more likely to hit those interference roadblocks we talked about earlier. It always comes down to that trade-off. Do you want peak performance, or do you want total convenience? So how do we plug into the biggest network of them all, the internet? Well, for most of us, it happens one of two ways. Either through broadband, where an internet service provider, an ISP, runs a physical cable right to your home, Or you get on through mobile broadband using the same 3G, 4G, or 5G signal your phone uses. That basically turns your mobile provider into your ISP when you're on the go.
Which leaves us with a final question to think about. We've seen the pros and cons, but as wireless tech like 5G gets faster and more stable all the time, are we heading for a future where we just cut the cord for good? Will all those physical cables that connect our homes and our offices one day just become obsolete? What do you think?